in the previous video we discussed density and we talked about density and its properties. In this video, now we're going to have a look at working out some problems involving density. So, as a quick recap first, remember that density is mass per unit volume. That is the definition. And that will lead us to the formula, which is density is equal to mass over volume. Okay, so remember, density equals mass over volume. In symbols, we write it rho equals m over v. That is the way as we usually quote it in terms of symbols in our formulas. And finally, in terms of units, remember that the SI unit for density is kilograms per meter cubed, but most of the times, many times, we use grams per centimeter cubed. Keep in mind that unless the question tells you, we have to use kilograms with meters cubed and grams with centimeters cubed. We don't mix these two. So get your stuff ready. You need your writing material and you will need a calculator here. Okay, we will be working 7 questions together. It's not much, don't worry. But first make sure, as always, to try them out yourself. First try them out, pause your video, and then continue them to see working the answers together, okay? So question 1. We're given an object which has a mass of 30 grams and a volume of 20 centimeters cubed. Find the density in grams per centimeter cubed and kilograms per meter cubed. So you have to give 2 answers using the different units. Try it out. Ready? Let's see what you've done. So, we have our formula, rho equals m over v, density equals mass over volume. In this case, we are given that the mass is 30 grams, 20 centimeters cubed is the volume, and I'm writing them on top of each other. It's good to include the units in the formula, but it's not always necessary. Here I'm just including them, especially so that you realize and you take note of the groups of the units that need to match with each other. What do we have here? We have grams and we have centimeters cubed. The two match, so we can leave them as it is. Okay, and if we work that out on the calculator, we get 1.5 grams per centimeter cubed. Now the question also asked us to give an answer in kilograms per meter cubed. And remember from what we said in the previous video, that to convert from grams per centimeter cubed to kilograms per meter cubed, all we have to do is multiply by 1000. And that will give us the next answer of 1500 kilograms per meter cubed. Question number 2. Mass equals 3 kilograms, volume equals 2 meters cubed, and again, the same thing, we find the density in both grams per centimeter cubed and kilograms per meter cubed. Try it out. Ready now? Okay, so let's have a look at what you've done. So in this case we've got rho equals m over v, again our formula standard, density equals mass over volume. 3 kilograms over 2 meters cubed. We take note of the units, kilograms with meter cubed. It's fine, I can work it out. So we work that out and that will give us 1.5 kilograms per meter cubed. Once again, the question asks us to provide it in both sets of units, so in this case we need to convert it to grams per centimeter cubed, and we can divide this time by 1000, and that will give us 0.0015 grams per centimeter cubed. It is easier to do the conversions of the answers if you keep in mind this conversion of the times or division by 1000. Alternatively, you can stay converting the kilograms and the meters cubed into grams and centimeters cubed and work it out again. It will bring you to the same answer. This sometimes is easier. Question number 3. mass equals 40 kilograms, volume equals 20 centimeters cubed. Find the density. Try it out. Ready? Let's see what you've done. So, once again, we write our formula. Density equals mass over volume, rho equals m over v, 40 kilograms over 20 centimeters cubed. But wait. Hold on a moment. If that is what you wrote, then that is not correct. Why isn't it correct? Because if you look at what we are given, mass 40 kilograms, volume 20 centimeters cubed, the units here do not match. Remember that unless the question tells you, which in this case it didn't, we cannot combine kilograms with centimeters cubed or grams with meters cubed. Kilograms must work only with meters cubed. Grams must work only with centimeters cubed. So here we need to do a conversion before we can continue. Now the question here didn't specify the answer in what units it needs to be given, whether it has to be done in kilograms per meter cubed or grams per centimeter cubed. So to a certain point in density we tend to choose ourselves, although once again, especially if you're in doubt, stick to the SI units, which are the kilogram per meter cubed. But nevertheless, as an example here, we're going to use both. Alright, we're going to work it out twice using converting the kilograms, the mass, and the volume. First up, we have to convert kilograms to grams. Remember, 1 kilogram is equal to 1000 grams, so I multiply by 1000. That will give me 40,000 grams. Once I have this, okay, I can use the formula density equals mass over volume, 40,000 grams over 20 centimeter cubed, and we get the answer of 2000 grams per centimeter cubed. Alternatively, instead of converting the mass, we convert the volume. To convert from centimeters to meters, remember that we divide by 100. Now in this case we have centimeters cubed to meters cubed, so we have to divide by 100 cubed. Okay, so that means division by 100, division by 100, division by 100. So we have to move the decimal point 6 times. Once I did my conversion, I can use the formula density equals mass over volume, 40 kilograms all over 0.00002 meters cubed, and that will give me the answer of 2,000,000 kilograms per meter cubed. A lot of zeros, we have 6 zeros over there, so that's 2 million kilograms per meter cubed. Finally, if we compare the two answers together, again, note the conversion applies here. Between grams and kilograms, it's just a question of multiplying by 1000. So I have 3 extra zeros. Question number 4, we're given the density, this time 3 kilograms per meter cubed. We're also given the volume, 0.8 meters cubed. We need to find its mass. Work it out. Ready? Let's see. Well, starting off, this time we need to turn around the formula a bit. Why? Because we need to find mass, not density. So density equals mass over volume, alright? But we need to make the mass subject of the formula, and that means that currently the volume is division, is being divided by the mass, it's underneath. And if within quotes we say we take it on the other side, right? It becomes a multiplication. So mass is equal to density times volume. And once we do that, we have our working mass equals density times volume, 3 times 0.8, 2.4 kilograms will give us the answer. Note that in this case, the units were matching. volume was in meters cubed, density was in kilograms per meter cubed, so we didn't have to do any conversions. So question 5. This time we are given the density, which is 6 kilograms per meter cubed. We are given the mass, 450 grams. We have to find the volume. Try it out. Ready? Let's see this. Well, this time we are asked to find the volume. And that means that we need to rearrange the formula to make V subject. Now we shall do this, for the sake of our example, in 2 steps. Okay, just so that we don't get mixed up. The volume is currently division, so again within quotes we take it to the other side to become a multiplication. Remember that technically this is not correct to say that we take it to the other side. Alright, but it's an easy way for students to understand. And this gives us mass is equal to density times volume, like we've seen in the previous example. But since this time we want the volume to be on its own, we want the volume to be the subject, the row must be taken to the other side again. It is currently being multiplied, so if I take it to the other side, it becomes a division. And that will give us volume equals mass over density. With practice, you can just swap around the volume and the density. Okay? Next we have to check the units, and here we've got the units which don't match. Density is in kilograms per meter cubed, but mass is in grams, it's not in kilograms, so we cannot work it out. In any formula you cannot work out when you've got, for example, mass with 2 different units. You cannot work out a formula where you have on one side mass in kilograms and on the other side mass in grams. That is not possible. It is totally incorrect. And this means that we need to convert one of them. If the question doesn't specify, it's really up to you. As I told you before, if you are in doubt, stick to the SI units, kilograms and meters cubed. Okay? So for the scope of this example, we will convert the mass into kilograms. Now in this case, 450 grams to kilograms, we just divide by 1000 and that gives us 0.45 kilograms. Once I've done the conversion, I use the formula volume equals mass over density, 0.45 division by 6, and that gives us a volume of 0.075 meters cubed. Finally, if you decided to go the other way, convert the density initially to grams per centimeter cubed, or you were asked to find the volume in centimeters cubed, you should end up with this answer here, which is of 75,000 centimeter cubed. Alright? So, question 6, you've got a box and you have to find the density of the box. We're given the mass, 50 kilograms, but we're also given the dimensions of the box. So, 80 centimeters height, 60 centimeters length, 60 centimeters width. Find its density, okay? Don't panic. Just because you see a box and something different, you don't need to stay panicking. Remember, to find the density we need 2 things: mass, volume. Mass was given, volume, you have to work it out. What did we say before? You need volume of either a regular or an irregular object. This is a box. It is regular. So to find the volume of a regular object, we just use maths. Remember, volume is equal to length times breadth times height in the case of a box. So here we have 80 times 60 times 60, and that gives us 288,000 centimeters cubed. Now, the question didn't specify what to use, whether it is grams and centimeters cubed or kilograms and meter cubed. In this case, I'm going to stick to grams and centimeters cubed. It was easier to work the volume like that, but that would also mean that we have to convert the mass from kilograms to grams. Remember, kilograms to grams we multiply by 1000, so we convert the mass into grams, and then we use our formula density equals mass over volume and work it out, and you should get 0.174 grams per centimeter cubed. And this is our last question, question 7. In question 7 we have to find the density of that stone. Okay, now we are given the mass of the stone is 650 grams. And also, since it is an irregular object, we have to use the measuring cylinder system. Right? We take the reading of the volume of the water without the stone, put the stone gently and take the volume again. And you can see the two readings over there. 40 centimeters cubed was the reading without the stone. When we place the stone, the reading of the volume on the cylinder increased to 60 centimeters cubed. Okay, so find the density now. Okay, so you're ready? Tried it out? It's actually easier to do this one. Okay, you just have to keep in mind how to find the volume and how to find the volume in this case. In this case it was very easy. All we have to do is subtract the two readings that we had. So 60 minus 40, and that means that the volume of the stone is 20 centimeters cubed. Once I know the volume, I simply use density equals mass over volume, 650 grams over 20 centimeters cubed. The units are correct, they match, and that will give us an answer of 32.5 grams per centimeter cubed. Well, that was the last one for today, so good job for arriving up till here, and it doesn't hurt to go over them again from time to time, okay, until you get the hang of them. And that is it for this lesson. In this video we saw some examples on density. Keep in mind the points we mentioned, especially those about the units. With practice, you'll get the hang of things. Hope you like this video, and as always, thank you for watching.